Good morning. Thanks for being here. We're going to talk about KSQL. KSQL is a thing to help us process streaming data that is in Apache Kafka. Now, in a room like this, where there are big bright lights up there and no lights on you, I can just barely see you. So when I ask for hands, I'm going to need to ask for like enthusiastic hands held high, and I'll just barely be able to make them out. Tell me who here is using KSQL right now, like in development or in production? Anybody? No hands. Kafka, using Kafka right now. That looks like 15, 20%. Very new to Kafka. Kind of not so sure about Kafka. A little bit familiar with Kafka. All right, good. I just want to get to know you a little bit. Let me tell you something about me. My name is Tim, that's true. I come from the United States. I live in Denver, a city by the mountains, and I work for a company called Confluent, and I run the developer relations team at Confluent. So my team's responsibility is, well, among other things like this, talking about the stuff that we do and really trying to make it easy for people to adopt Kafka and elements of the Confluent platform. So that's what I do, and I would love to be able to talk with you later in the day if we bump into each other here and you have more questions. So it's probably a good idea to give everybody just kind of a little bit of an overview of Kafka. Now, most of us have the sense that it is a distributed messaging platform. And some of us are kind of still holding on to, and this is very understandable, the Kafka of a few years ago. It really started life as a giant scalable queue, messaging queue. And it is that, under the covers at its core, but it's a little more than that. And it has kind of crept into this much larger architectural role. And for something like KSQL to make sense, like why you would even want a technology like KSQL, you need to understand architecturally what Kafka is all about. So I'm going to give you a little tiny overview of Kafka and a sense of what it wants out of you architecturally, how it wants you to build systems. Then we're going to dive into KSQL. We'll look at the syntax. We'll talk through some of the concepts in it. And of course, there will be live coding because, well, who doesn't want live coding, right? All right. And if you have questions, well, I always say put your hand up, but not in this room. So if you have questions, see me afterward. All right. Right here, you have the simplest Kafka architecture diagram you will ever see. It's also the most general. So every system built on Kafka, every piece of the Kafka and Confluent platform is basically conforms to this diagram. So Kafka itself is the thing in the middle. That's what we'd call the Kafka cluster. That's composed of a number of systems or machines we call brokers. And brokers are responsible for the pub-sub functionality, for receiving new messages and serving up messages to consumers, and for storing them, right? So that's what a broker does. It stores messages. You can publish messages to it, and you can subscribe to messages in it, and that's kind of it. And obviously, there's hours and hours of things that we could talk about in there for how Kafka does, how it manages replication and failover and consistency and all kinds of cool things like that. It's got a story, but for now, let's just say there's a cluster of brokers and they cooperate in the task of being a messaging system. Every application that puts messages into Kafka is a producer. And that producer is an API, that's a public API, and it's even a public wire protocol, so you can write your own language binding for it if you want, for you to get messages into topics in Kafka. So when I say producer, I'm referring to both an API that we can implement, that we can look at on its own, and when I say producer, I'm referring to an application, a program that you write that puts messages into Kafka. Likewise, with the consumer, that's an API, that's a wire protocol, and that also refers to a program, the program that you write that subscribes to messages in Kafka and does something with them, does some kind of computation on them and puts the computed results somewhere else. Producer, consumer. Everything you ever do with Kafka is going to be either a producer or a consumer. Now, those APIs, producer and consumer, are super duper low level. If you've programmed against them, you know. If you haven't, you can Google them, and it'll take you like 5 minutes to think about the example code and kind of get it. And let me tell you a little bit about Kafka's data model without even leaving this slide, so you can have a sense of what I mean by the producer and the consumer are a low-level API. A message in Kafka, when I say write a message to Kafka, a message is a key-value pair. All right, now that has some sort of typing in whatever language you're using. Kafka, under the covers, doesn't care about the type, but of course our language will probably be typed in some way, and so, you know, the key will be a string and the value will be some blob of JSON or something, whatever, right? So the message is a key-value pair. The message is probably pretty small. A few tens of kilobytes is kind of getting to the big-ish range for Kafka. You don't usually put like media in there. Messages usually correspond to events, which I'll talk about in some other talks later today. But that's kind of it. It's a key-value pair. You put it in there, and you put it into a thing called a topic. Inside the brokers, inside that Kafka cluster, there can be many, many topics. Topics are just named queues of messages. And that's kind of it. That's the data model. That's what there is to know about how data is organized in Kafka. And the producer, that API, all it knows to do is to say, well, there's a topic named movies, and here's my little movie key value pair, and I'm going to write it into that topic. That's it. That's all you get, right? Consumer, same thing. Consumer, you say, well, there's a topic called movie ratings, let's say, that borrowing from the example later on. There's this topic called movie ratings out there, and in the consumer you say, hey, Mr. Broker, let me know anytime a message shows up in the movie ratings topic, and when one does, there you get it, you get a key value pair, and here you go, here's your key value pair, do some kind of computation with it, all right? Very simple. I don't even have any code. I don't even have anything illustrating that. But I think you get it. Even if you've never thought about that API before, you can kind of understand that in 2 minutes of talking. That's the good side. The downside is that API is not doing too much for you. And that's going to get to be a pain later on. We'll come back to that. That's really what KSQL is all about. So, producer, consumer, very, very simple, easy to understand, also not helping you out a lot. Let's look under the covers in Kafka a tiny bit more so you can appreciate what it is doing for us and what it's all about. Now, the big box in the middle is a topic. Like I said, topics are the fundamental unit of organization in Kafka. When I write messages into Kafka, I'm writing them into a topic. And you see that producer over there on the left is writing to the topic. The topic, though, in order to scale, is split up into partitions. When you create a topic, you get to specify how many partitions you'd like it to have. In the demo later on, I'm not going to do that. They're all just going to auto-create, and they're all going to be a single partition because that fits nicely on the laptop. But in real life, you don't want a single broker or a single machine to have to do all the work of storing messages and all the pub sub, because these topics might get big, right? This system might scale to large sizes. So we take topics and we split them up into partitions. Each partition then can live on its own broker. And so when the producer is producing, it says, hey, I've got this key value pair, and I want to write it into the movie ratings topic. It has to decide what actual partition to write it to. And usually it does that by taking the key and hashing it. And so messages with the same key will always land in the same partition. By default, messages with the same key then are always going to be consumed in order. But in general, we don't know if we're consuming all of the produced messages in order. Once you partition, you give up on global ordering. And that becomes an interesting topic that we could say more about in a different discussion. But basically, partitioning is what we do. Consumers then, over on the right, there's some interesting functionality packed into consumers to help us scale. Because we don't really know, in general, how expensive the work of consumption is going to be. Some consume processes might be really lightweight, some of them might be really expensive, and some kind of expensive consumer computation, you're going to need to scale that thing out. And you might want to scale it out for fault tolerance anyway, right? So I have two, in this diagram, we have three partitions, and two different consumer applications. They're called Consumer Group A and Consumer Group B. They're doing completely different things. We don't know what they are, but they're just different applications consuming those messages in different ways. Both of them have to consumers. And as you can see, if you follow the arrows, that very top consumer group A instance is consuming partitions 1 and 2. That second consumer group A instance is consuming partition 3. That assignment is automatic. So if I had just one instance, say I started up consumer group C, and I only deployed one instance of that consumer application, it would be consuming all 3 partitions. And I can elastically scale that application by just adding new instances of the application, spinning up new containers or whatever it is, however it is I deploy code. I can spin up a second instance, I can spin up a third instance, and for as many partitions as I have, I'm able to scale out that consumer group. And that, by the way, is automatic. So when you're writing your consumer code, you don't have to do anything directly to think about that or enable that. That's just a thing that Kafka does. By virtue of you being an application that consumes messages, you have access to some elastic scalability and some fault tolerance functionality right out of the box. It's pretty cool. So you've built a little elastically scalable, fault tolerant distributed system without even trying. Now, that's kind of, again, the basics. Topics are partitioned. Producers hash the key, figure out what partition to write to. Consumers consume from partitions, and depending on how many consumers you have, the cluster will assign partitions to consumers as needed. The fundamental data structure or abstraction at the very bottom of all of Kafka is inside each partition. Really what each partition is simply a log. This is what Kafka is. The producer puts new messages on the end of the log. That's the only place it can write them. Once it has written them, they do not change. I cannot go back to message at offset 3 and alter that. It is immutable once it's written. And that is a very important principle. That enables a whole bunch of functionality. And a whole bunch of architectural paradigms now are possible because that data is immutable. So producers produce to the end, and I can have, in theory, any number of consumers reading from this topic. Here I have 2 of them, and they're at different offsets. That's okay. Consumers can seek backwards to a particular offset or a particular timestamp in a partition, or they can, if they're caught up, they can just consume the most recent message. I guess there are 2 important things there that make Kafka a little bit different from legacy messaging systems. One is that it stores data. The act of reading a message, of quote-unquote consuming a message, doesn't make the message go away. That just means that you've read it. It's still going to be there, stored in the topic, until the data retention policy says that we can get rid of it. As a result of that, we can have multiple consumers consuming from different places. So that I can have one topic full of data and many applications. I can deploy many applications to do computation over that data in different ways. So there you go. What this does, and what I'm about to say, I'll admit, I haven't quite made this argument. I've got a couple talks later on in the day that I think make this argument a little more coherently. But Kafka doesn't just want to be a big giant pipe to get some events from over there into some system to store them. What it really wants to be is a distributed commit log that's the backbone of your entire system. It wants to be, as much as possible, the system of record. It says, really what you're doing is you're processing events. And that's all any software does. Things happen. We become aware of those things, we do computations over those things and produce useful results to people. And Kafka is saying, look, yeah, everything's an event. I'll store the events for you, and I'll give you ways of doing processing over those events. I'll give you ways of integrating legacy databases that aren't evented systems, but are regular old update-in-place databases like relational databases. I'll give you ways of capturing changelog streams for those and making those just data in topics, and integrating those applications. Those would be microservices, really. Kafka as a messaging backbone becomes an intelligent way to integrate microservices as well. So there's all kinds of things we can do this. And if it seems like I'm just kind of saying that, and not really backing that up. There are a couple of talks on that theme that I'm giving later today, and come to one of those. You don't have to come to both, but just come to one, and I'll make that case in more detail. But that whole, and that stream processing, those orange boxes in there, once I've got data in topics, what do I want to do with it? Well, if all you had was the consumer API, right, and you could read a message and do stuff with it, things are going to happen, all right? If I set you loose and told you about it and you said, yeah, that's awesome, I'm going to go build things, you're going to find out that over the next year and a half, certain things will happen. Like you're going to have to group things by key and count them. That's probably going to happen. You're probably going to have one topic that's got some data in it that has a key, something like a foreign key that points to some other lookup table somewhere, and you're going to have to join that one topic with a table, or maybe join it with another topic. Or these are going to happen. You're going to have to chunk the data up into windows, right? And if all I give you is the consumer, you're going to have to go write that. And it's fun, right? It's fun to write framework code. It's better than business code, right? Because the regular business code, there are insane stakeholders that want like weird exceptions. You build some beautiful data model that says, okay, we've got one promotional activity that can happen every day, and the schema won't let us have two of them, so we'll never double up and do two at once. Okay, it works, and then you go and demo it, and the product owner goes, okay, great, what about 2 for Tuesday? What's 2 for Tuesday? Well, on Tuesdays we have to send 2. Like, that's business code. It's always messy and weird, and there are exceptions. Framework code's not like that. So, it's tempting to want to go write the stream processing engine because you can make it beautiful and perfect. But, then you get fired because you're not actually delivering features, you're building frameworks. And that is where KSQL enters the picture. These things that you're going to have to do with data in topics, KSQL is there to do them. It's a declarative stream processing language. It is not a subset of ANSI SQL, but darn it, you're going to find that it looks suspiciously like SQL. Let me show you what it looks like. Now, that code on the screen right now, I think you could be forgiven if you just thought it was SQL, because it sure could be. The only thing that makes that not SQL is that Clickstream. And where is Clickstream? Clickstream right here is not a table. Clickstream is a stream. And this is one of the two primitives that KSQL works with. KSQL also does have a concept of tables, but first and foremost is a stream. Now, a stream is lightweight abstraction on top of a Kafka topic. And so underneath Clickstream, there's a topic called something, we don't know what, and we've told KSQL, hey, there's that topic down there. We want to call it this stream Clickstream. And every time a message arrives in the topic underlying Clickstream, run this query and emit a result. And this, you can see this is just a stateless filtering operation. This is getting Clickstream events from some surely GDPR compliant Clickstream measurement system out in that we've installed on our website, and we're filtering it to only show clicks from IE6 users. That's what this code does. Hey, maybe that, might be interesting. You want to know what those IE6 people are doing. I've often thought, I think we're in this weird in-between stage where IE6 jokes are like almost not funny anymore. Like 4 years ago, there were still like, oh yeah, they make us support it. It hurts so bad. And now it's like, well, no, that's kind of done. I think in another few years, I'm going to keep it alive. I'm not letting it go, right? In another few years, we'll be at the point where we're ready for the pure JavaScript IE6 emulator that somebody's going to write. Like that'll become an interesting project to do. We're in this weird IE6 trough. It's not nostalgic yet, and the pain is fading. Anyway, some more KSQL. This query introduces a couple of things, and I want you to, for now, ignore that top line. Just look at the second line. It says select user ID page action from Clickstream left join users. I don't even need to explain what's happening there because you know SQL and it's fairly intuitive. But there is something tricky here. So Clickstream we just talked about. That's a topic of clicks that some external click measurement thing is emitting, is producing into that topic, and we are consuming them here. Users isn't a stream. Users is a table. And this is the other kind of primitive that KSQL has. KSQL supports streams, and it also has a concept of tables. Now, underlying users, where are those users stored? Well, you have one option for where you can store things. That's Kafka, and Kafka has one kind of thing that it can store data in, and that's a topic. So it's fairly straightforward to understand how Clickstream, as this thing we're calling a stream, is an abstraction on top of a Kafka topic. It's a little weird for me to tell you users is a table, and it's an abstraction on top of a Kafka topic. So let me explain. Remember I said that the things that go into topics are messages, and messages are key value pairs. And that's like almost all you really need to know about the Kafka data model. Messages are key value pairs. Topics contain messages. Well, imagine if we had a topic that contained updates to user records. So it's like a change log, okay? Updates to user records, and every time somebody edits their profile, we produce a new message into this topic where the key is the ID of the user and the value is some, say, JSON blob or Avro serialized thing or whatever it is we want. The key is the user ID. The value is the updated user record. Now, if somebody's crazy and they're editing their profile every minute, well, there'll be a new message every minute. That would be kind of weird and frankly unlikely. Most people don't edit their profiles all that often, but every time you edit your profile, produce a new record into that topic, right? Well, KSQL, in creating a table, is simply saying, I'm going to get the most recent one of every message in that topic, the most recent value, and I will materialize that as an in-memory view of the data in that topic. And that's it. So maybe there are 1 billion messages in that thing from all these profile updates for the last some number of years, but I'm only going to have the current version of each one in this table. And that's actually going to be kept in memory, and there are important reasons for that. So that's what a table is. A table is just this materialized view of data in a topic. And as long as that is sort of change-loggy data, that works just fine. Now, some questions that I'm sure you'd ask right now, and some of you are thinking is, oh no, in memory, well, too bad that's not going to scale, right? Let's just stop there for a second. I hear your skepticism. But remember how Kafka wants to scale consumers. We have topics. Topics get partitioned, and you can have a consumer group. You can have as many instances of that consumer application as you have partitions in your topic, right? Well, what is KSQL but under the covers? It's a producer and a consumer. I said everything that talks to Kafka is fundamentally a producer or a consumer or both, and KSQL is no exception. So the engine that's executing this code, and we'll get to that at the very end after the demo, the engine that's executing this code is a Kafka consumer group. So if I have a very, very large user table, well, or collection of users, I'll want to partition that, and then I'll want to scale out my KSQL server group so that everybody can fit that little chunk, their partition of users in memory. And that is off-heap memory. This is Kafka's all written in Java, but the state store, if you're interested, comes from a Facebook project called RocksDB. So inside KSQL, there's this RocksDB instance that's keeping that stuff off-heap and is able to just basically deal with memory in a not crazy way. Anyway, there you go. You basically get what's happening here. This is a join. The interesting thing is stream and table. Those are concepts you have to know. Now, I told you to ignore the first line of this query, and I would like you to stop ignoring that first line and pay attention to it now. Create stream as select. Internally and informally, we call this a CSAS, C-S-A-S, create stream as select. And what we're telling KSQL is, don't just run the select, but go kind of like spawn a continuously running persistent stream processing program. And you'll see this in the demo. I'll do a select and I'll do a create stream as select, and you'll see how they behave differently. But threads are spun up and a thing is running inside the engine when I do this. And the results of the select are being produced to a new stream called VIP actions, which by default, if I don't tell it otherwise, will overlay a topic by the same name. So this KSQL query will be producing records, producing messages to a topic called VIP actions. And that, I can consume that directly. I can Kafka connect it out to a relational database or S3 or whatever I want to do. It's a Kafka topic. It's a part of the Kafka platform, and I can do anything I need to with it. But point is, I'm producing it with this KSQL query. All right. Almost done with static code and ready to look at code that I type. One more here. This introduces two new concepts. I'm creating a table, that create table as statement, but let's walk through the rest of the query. Select card number and count from authorization attempts. So this is a fraud detection algorithm. Anybody who works in financial services, you are welcome to have this algorithm, no extra charge, very sophisticated. Get out your phone, take a picture of the slide right now. It's amazing. And you're laughing. Wait, why are they laughing? Authorization attempts is apparently a topic full of credit card authorization attempts. And we're going to group that. Notice I'm skipping the window for now. But let's skip down to the group. I want to group that by card number. And anytime I see the same card number appearing more than 3 times, I would like to emit that card number and the count into the table. So I'm flagging it as potential fraud. Now, of course, I don't want that to be over all time. That would be a rather unfortunate credit card that I could only use 3 times, although I have one that I think their fraud detection algorithm is something like that, because it seems like I'm getting a new one every couple months. I don't know what I'm doing wrong. The window statement in the middle is key there. So this aggregation, this counting, is going to only take place inside 5-second windows. So I need to see more than 3 uses of that card within 5 seconds. And so if there are, say, 4 authorization attempts in 50 milliseconds, then right away, that card number and the number 4 will be emitted into possible fraud, into the table. We don't wait for the window to close to produce results. We're always producing results. But if I see 2 authorizations in the first 50 milliseconds, and then 6 seconds later I see another one, that's defined as not fraud, at least not by this algorithm, because that's not within the same 5-second window. So windowing, there's a much longer story to talk about there. I just want to introduce you to the concept. There are a couple of other windowing schemes that you can use, but this is just the basics here. Let's go ahead and look. I wanted to show you very quickly the DDL. So for Kafka, for KSQL to know about a topic, you have to register the topic as a stream, and that looks like this. Looks a lot like a create table statement with a little vendor extension on the end. Create stream, Clickstream with metadata, and then we're going to say that the Kafka topic is called my Clickstream topic, and it contains JSON data. I could also say the value format is Avro. KSQL supports Avro and JSON. Any serialization format you want, as long as it's Avro or JSON. And that's what the stream creation DDL looks like. Here is the table creation DDL. It's almost exactly the same, except I also have to specify the key column that we're going to use as well. And I will actually do these things. Well, now, I think, let's do a demo. All right. Hey, I know them. Let's go here and okay, that's still a little small, actually. I hope that's good enough. We'll see how this goes. So I have the Confluent open source 4.1 distribution running here, and KSQL is a part of the Confluent open source distribution. It is at present licensed as Apache Public License 2, same as Kafka itself, and you can go and you download this. Well, you can go to GitHub and build it from source. It's actually not very hard to do. You could download it from confluent.io/download, whatever it is you want to do. But I'm running it, and it has this handy-dandy command line tool that's good for development and demos and things like that. It's not a production tool. In fact, in the next release, every time you type it, it says, hey, don't use this for production, please. Because some people were, and it was making people sad. Let's go ahead and run KSQL. And so this is the command line version, perfect for experimenting, running locally. You can connect to production instances with this, but we're not going to do that. So let's see here. All right, I'm going to shrink the font a little bit so it doesn't wrap when we list the topics. There we are. Those topics are just the internal ones that come with the platform when it starts up. It's like some Kafka Connect stuff and schema registry stuff and one KSQL-related topic. Basically, let's just ignore those. We do need some data, though, and that data is going to be this. This should be easy enough to find. It is. Good deal. We're going to rate some movies. I have an idea for this movie rating app where instead of just saying after you watch a film what you think of it, you'd actually go and use the app even though the movie theaters kind of hector you. Like, whatever you do, don't open your phone because the light will blind people. I don't quite know what that is. But, you could actually get your phone out. Movie theater would hate you for this, but this is just my app idea. Totally fictional. And rate the movie like while you're watching it. That'd be kind of interesting. You could get like rating data like, wow, that opening action scene was really great, but things kind of bogged down in the second act, and okay, the fight scene was good, but the ending sucked, or whatever. You can just kind of get an idea over time. It'd be valuable data. So that's kind of what we're doing here. I have a couple of JSON files. I got this one that's all these movies, just all kinds of information about those movies, and I have a script that I'm going to run that's going to create data that looks like this. I'm not going to use this static file here, because that would be boring. I want real-time random streamed ratings, but it's just going to be a movie ID and a number. So let's take a look at how to deal with this. I want to take just one record from my movies JSON file and produce that into Kafka. Let's see, produce into topic, movies, raw. Let's see, is that going to work for me? I think it is. Excellent. Let's go over here and list my topics. Oh, look, I have a topic called Movies Raw now. Now, KSQL will give me kind of some primitive debugging capabilities of like peeking into a topic and seeing what's there. But what I really like to do is something like this. Right? I'd like to do a select from a stream, but that stream doesn't exist. Oh, hey, wait. Things are a lot more fun if I do that. So let me create a stream called Movies Raw that has the following metadata. Title, we'll give it a title, and we'll give it a release here, right? And value format is JSON. Why? Because it's much more pleasant to look at. And the Kafka topic was called, I believe, movies-raw, because I like to do that. And now I have a stream. And now I can select from that stream. Class dismissed. No, you can't go yet. It's not cool enough yet. So let's put another record in. I'm going to grab a record from the end of that file, and I won't be able to get over fast enough to the other tab, but you see now we have two things in there. And I can keep doing that for a little while. I can just keep putting records in there. Those are duplicates now, but we'll see what happens. We'll see if we can get rid of those duplicates in a minute. What looks bad about that? So it looks like I have the ID, the title, and the release here, This is probably a timestamp. What is this? Somebody shout it out. The key. You're very shy. Somebody knew that, and you didn't shout it. But that's the key, and that's null, because that's what Kafka Cat does. Kafka Cat is just a little third-party open source Kafka command line utility written by actually a great guy, a guy named Magnus, and it's a super great utility. You should use it if you don't. But it makes the key null. I need the key to be movie ID in order to do that join. That's just somewhat intuitive, right? Let's set that up. So I've got movies raw. Let me create a stream called movies rekeyed as a select star from movies raw, partitioned by movie ID. Aha, I can repartition. Now, notice that before, when I created that stream, it said stream created. Now it says stream created and running. That's because the first create stream was just DDL. Just said, hey, there's a topic here, I want to register it. This one is a create stream as select. So this is a program. And this stream processing program is running. It happens that my underlying topic has one partition, so it's only created one thread. But if it had 10 partitions, there would have been 10 threads just spawned there, ready and waiting, consuming from the underlying topic. So now I can select star from movies rekeyed, and it looks much better. But that's not really what I want. This is lookup, this is reference data, the movie stuff, right? It's not really a stream, it is a table. And so I want to create a table. Usually it's conventional to give them a name also. There we go, movie ID, title. So that's that same metadata there with, it's a table, so remember I have to give it a key, this little quirk of nature here, value format will be JSON, and the underlying Kafka topic is going to be movies rekeyed. So that movies rekeyed stream that I created is producing messages into a topic called movies rekeyed. And now with this DDL here, I'm saying create a table from the messages in that topic. So, and this is, by the way, intentional that this is a part of the demo, because this is just real. You get things that have the wrong key. And there's a join that you want to set up to do, and you have to repartition. It's totally fine. Of course, I am copying stuff, right? My create stream as select to rekey the movies is taking the original movies topic and copying that data to another topic. That's like denormalizing, and that's immoral, right? You're a terrible person if you do that, except not here, right? There's a storage cost to copying data, and we deal with that. But usually the thing that scares us about copying data is, what if something changes, you have to go change it in the copy? Well, the data is immutable. Every message in Kafka is immutable, so you can copy things as much as you need to, as much as you can afford to, and you don't have any data integrity concerns. You just have storage and I/O concerns that you have to optimize for. So what we're doing here, in other words, is just fine. Now select star from movies, and you'll notice that I only have 2 records now. Those duplicates have been eliminated, and only the most recent versions of each one of those things is included. Now, I'm going to get going here, and I'm just going to dump the rest of my movies in. And, oh, I made it over in time. There we are. We have everything. I see Zombieland, Wreck-It Ralph, Dr. Zhivago, The Day of the Beast. I don't know if that's a movie I can recommend. So, that's just on you. We've got our reference data. That's all nailed down. Now let's get some ratings happening. Now, it so happens that I have a little piece of groovy code here, that Gradle is going to run for me. And what it's going to do is it's going to pick about 10 or 15 movies and generate some randomized ratings based on some realistic averages that someone with impeccable taste in film has put together for us. And I'll let you guess who that might be. Okay, we have a new topic called ratings, and we need to register that. I want to create a stream called ratings, and it's going to have a long movie ID, and it's going to have a double rating, and it's going to be JSON data, and it's going to come from a Kafka topic called ratings. It's okay to call them both the same thing. And so I now have registered that, and I can select star from ratings, and oh boy, isn't that exciting. Now, I have cheated, and the script that is producing messages into this topic is producing them with a key that is joinable. So you see that it's not displaying very well in the UI here, but that second column, that's a key that is ready for us to join. So I don't have to mess with this anymore. However, it's not useful. It's just an ID and a number. You know, maybe I could at least, let's see, select title and rating from ratings, left join on movies, on ratings, movie ID equals movies, movie ID. And okay, that's better. I'm going to let it finish. I don't want to interrupt it. Let's just let that print for a second. You can see there's names and numbers. Still, you know, if you'll permit me, I think it's still kind of stupid. And okay, good. You can see that all. Good. So it ends with Lethal Weapon, classic Christmas film, at a 8.27, which I think is a pretty honest rating for that movie. So there you go. What have we got here? Notice a weird state that this is left in. I want to point this out. When you type in a select at the command line, this is how it stops if there's no data coming into the stream. I stopped my script just to keep things under control for now. I'll restart it by the time we're done. But selects don't finish. It feels broken. Every time you do this, you have to hit Control-C. And at first, it's like, well, that's kind of weird. Why should I do that? Well, it's streaming data. When is it ever going to get the last message? It's just going to run until you stop it. And these selects that we type in at the command line, they're these non-persistent queries that just run right now. To make it a persistent query, I have to do a create stream as select or a create table as select, which I'll do in a little bit. Now, let's make this a little more exciting. Films are ambiguous by title. We need title plus release here. And so we're going to add that there. And I don't really want just the rating. Ratings. No, I definitely want ratings. I want the sum of rating divided by the count of rating. And I want to name that average rating. And then I want to group this by title and release year. So now I have average ratings. And to do that with, if all you had were an API that said, here's your next message, there's a lot you have to do to make that happen. That's actually pretty difficult. We haven't talked about state management, but to do this, to aggregate based on a key and then do computations over your grouped keys, that is a stateful operation. There's stuff you have to keep in memory. Creating the table is inherently stateful. There's stuff you have to keep in memory. KSQL does that for you. It's built on an open Kafka API, a Java API called the Kafka Streams API. Kafka Streams handles all that state for you. And otherwise, if all you're doing is programming directly against the consumer API, you have some fairly thorny state management problems that you have to deal with. All of those kind of evaporate in KSQL. They're handled for you by the engine. Now, what's the one thing I want to do after this? I want to create a table called rated movies as this select. Now the table is running and I can select star from rated movies and I'll go start up my rating script again and we'll see, select star is a little ugly. Let me It turns out I don't have any remakes in my list here, so we can just do title for now. But there you go. This is going to continuously update. My fans are going to kick on. You can't hear them, but we're already at 200,000 movie ratings here that are being aggregated. And I haven't defined any windowing, so it's going to be aggregating over everything. This is going to get out of hand after a little bit, but there you go. We are successfully doing stream processing with just a few lines of SQL. And you can see my movie recommendations, like Super Mario Brothers, just didn't really, maybe it's time for a reboot. I don't know. I don't think it happened. What else? We have Children of Men. It's okay. Where's Tree of Life? It's like a 10. Best movie ever made. Hear me now, believe me later. Anyway, you get the idea. Let me just explain maybe one more thing. Here we are. This is something like what we were just doing. I had that CLI running, that command line interface, and it was talking to, basically, in this case, in the debug mode, an in-process KSQL engine. And that engine parses the KSQL, builds a little stream processing application, and runs it. The producer and the consumer stay, they're internal to that thing, and it's just doing the stream processing code. To run this in production, you're probably going to work out your KSQL, and your KSQL really is you writing stream processing programs in this SQL-like language. You'll put that into a file, deploy that file with the server, and scale out your KSQL cluster to whatever the need is. You could do 1, you could do 3, you can do 10. It just depends on the volume and the complexity of your processing, and run that in the cluster. Those nodes in that cluster act as a cluster. One of them can fail, and the partitions that are assigned to it will be failed over to another machine, and the state will move with them. The state's all managed for you. You can elastically scale it out, add more nodes, add more KSQL nodes, and partitions will get assigned to those. The whole business of being an elastically scalable, fault-tolerant application is handled for you by that engine. Basically, you've got a script called KSQL server start that you run in the container or on the VM or whatever it is, and there you are. You're a KSQL engine. And typically in production, you're just going to run from a file of code. You can also, of course, run in production like this. You can have a KSQL cluster, connect to it from the command line, and issue queries that way. That's completely fine. But that's what it looks like to actually run this thing in production. If you want to know more, you could check out the code. It's on GitHub. KSQL is open source. Confluent Inc./KSQL. There's some documentation in there. Most of the documentation has moved off to docs.confluent.io, but there's some docs and examples in there. Confluent.io/KSQL will give you some tutorial videos, the guy who looks and sounds like me in them, if you want to dive a little bit more deeply. We also have a Slack community, which is operated by my team and is peopled by actual KSQL engineers. And if you have even very difficult questions about it, you can probably get them answered in there when you're just getting started. So check that out, join Slack if you're interested. And hey, find me later. This afternoon, I might be a little jet laggy, but I'm going to try to be around. And I would love to talk to you more about this. Thanks for hanging out with me and your patience and your interest.